Let's do it. Unit testing. So the lecture question today, we do have a good jump up in difficulty, at least in my opinion. I'm sure you all let me know. For this lecture question, I'm asking you to compute the prime factorization of an int. So given some int, give me all of the primes that were multiplied to be able to get that int. With a few special conditions. If the input is negative or 0, return an empty list. If the input is 1, return a list containing only 1. And if the input is anything else, any integer 2 or greater, do not include 1 in the prime factorization. So for example, if we want to factor 12, we have to return the primes 2, 2, and 3 in a list. But that list can be in any order. We're not specifying the order of the factorization that's returned. So a few questions here, and the big part is testing this, of course. The method itself is fairly challenging, and then the testing is what we want to think about. So when we return this list, first, how do we check a list in our unit test? And second, how do we handle this ordering, this fact that there are multiple solutions, multiple correct solutions for a particular piece of functionality? So these are the two things we want to think about during this lecture question. All right, for today's lecture, we're going to continue talking about unit testing. And today's lecture is going to be a lot of examples. Excuse me, I shouldn't say a lot, 2 examples, if that's a lot. It's going to be a lot of live coding, though. I'm going to spend a lot of time in IntelliJ just walking through 2 questions. We're going to make mistakes along the way. You can laugh at me when I have typos and stuff. And I want to give that more of that realistic feel. When we have lectures with slides and stuff, everything looks really nice and shiny and perfect because we spent a lot of time debugging those examples. I want to show more of the process of developing and show you how to use these concepts. Plus, last time, in this section particularly, I really didn't get to the example at the end of lecture. I was going to go through an example of running Maven, working with POM files and stuff. Most of you have probably struggled through this and figured it out to get the lecture question on Monday, but I want to go through that a bit slower and explain exactly how to get that set up to make sure everybody's up to speed on getting Maven set up, downloading Scala tests, and setting up a testing project. To that end, the first example is going to be going through the lecture question from Monday. I'm going to walk through this, how to test it, how to solve it, just to make sure everybody's absolutely clear on the structure of these lecture questions and what I'm asking you to do for these questions. And as a kind of logistical note, not purely logistical, but the lecture questions are due at 11:59 p.m. the day after the lecture. That's the due date, but I leave the submissions open, so you can still submit after the due date. Now, when I'm looking at learning objectives after the 3 weeks, the 2 weeks of lecture, and then the week of lab, after that, when I'm looking at your learning objectives to see who's completed that or not, I will take that into consideration whether you submitted the lecture question or not. So if you submit it and get it correct after the deadline, that will be significantly better than just not doing the lecture question at all. So you can still submit Monday's lecture question. I'm going to go through the how to do this as a live demo, so there's really no excuse to not get this lecture question after today's lecture. It might be late, but I will take that into consideration. I'll also, since there's no points or anything in this course, I can take things into consideration like that. For example, I didn't get to the demo the way I wanted to at the end of this lecture on Monday, and then threw you into the lecture question. So if you're late on Monday's lecture question, I'm going to understand that, well, I didn't really get to the concepts in lecture that I wanted to get to. I understand if you didn't quite get unit testing up and running, Maven up and running, Scala test up and running for that lecture question. So you can still submit, and I'll see that it's late, but I can still work with that. If you don't submit it at all, there's no excuse to not get Monday's lecture question after today's lecture. If you don't submit even late for that question, that makes it an easy decision for me. That's an easy, unless you did a lot of the other stuff, it's an easy no, unfortunately. That'll look really bad. Anyway, let's go through this lecture question with all that in mind. So I had this slide after the lecture question. When I have extra slides after the lecture question, I usually won't show them in lecture unless I accidentally click. Sometimes that happens. But I won't show that extra slide, but if you download the slides, you can get the extra content. But I have this slide after, and I want to explain what this is, what's going on with this lecture question. So whenever I have a question, which will include any of the numbered objectives in any homework, and some of these lecture questions as we're introducing unit testing, we're going to have in AutoLab a good number of incorrect solutions in AutoLab. So I want to know if your tests are doing what they're supposed to be doing, and a proper test suite should be able to tell, given a method, is this method correct or not? So what I'm doing in AutoLab is running your tests against your own code, your test against a correct solution, my solution for the question, for the objective, and then any number of incorrect solutions. For this question, and then you'll get feedback on whether it passed or failed on that one. For this lecture question, I had 5 incorrect solutions, and when you submit to AutoLab, it'll say whether your test passed or failed each of these 5 incorrect solutions. For this one, I gave you the code. I won't do this again, but I did it this time because I wanted to show you exactly what's going on here. So I had these 5 incorrect solutions. These are all incorrect compute shipping costs. For one reason or another, each one of these has some input where they're going to return the wrong output on that input. So if your test suite, if you're submitting your test suite to AutoLab, you're saying, I believe this is comprehensive testing. Any method, any implementation of compute shipping costs that passes my test suite, I'm confident that it is correct. So I'm going to run it against these 5 and say, well, if you pass any of these incorrect solutions, your testing was not comprehensive. It was not good enough because here's an incorrect solution. Your test suite said this was correct. That's no good. And the big concern here is, what if your submission, what if your code makes the same mistake as one of my incorrect submissions, but you're just not testing for that? How do you know that in your implementation you didn't make that same mistake? Now for this lecture question, the method was simple enough that, yeah, we can probably just eyeball this and tell if we're right or not on the method. But we're going to start seeing in today's lecture question, the second example today, some more complicated implementations where it's not so obvious, where we're going to have to lean on that unit testing a bit to be able to tell if we're correct or not. So, and with these, I have a slide on after, but I want to talk about it now, is if you satisfy AutoLab, if AutoLab says objective complete, that doesn't necessarily mean that your code is correct. I'll emphasize this throughout the semester. It doesn't necessarily mean your code is correct. There could be a mistake in both your testing and your method where I just didn't happen to make that same mistake in one of my incorrect submissions. My incorrect submissions are not meant to be comprehensive. There are going to be mistakes that can be made that I just don't have an incorrect submission for. I'm not trying to say your tests are comprehensive and complete and will check for every error if you get past that objective. The AutoLab is mostly saying, hey, you have a good start here. Everything kind of checks out, at least at one level for this. For this one, we're getting most of the way there. There's not too many errors that we can make in this method. But as we get to the homework objectives, I'm still only going to give a handful of incorrect submissions, but there are tens, dozens of things that you can do wrong in that implementation. I'm not going to check for every single one of those in your testing. So this is where you have to say, okay, I got the AutoLab. AutoLab says I'm complete on that part, but is it enough testing for you to be confident that any implementation passing your unit tests must actually be a correct implementation? That's how much testing you need to have. How much to convince yourself that your method is correct. And I'll give you a specific, semi-specific example on this. On the physics engine homework, last semester I saw quite a few students. In my incorrect submissions, there were some very common errors that I just didn't have an incorrect submission that happened to make those errors, and those errors turned out to be fairly common. There were quite a few students who made those errors, relied on AutoLab saying, hey, you completed this objective, and then stopped testing as soon as AutoLab said they were good, and then moved on. Well, they got to the primary objective. The primary objective is calling their code from the previous 3 objectives. Primary objective, calling incorrect code. They didn't do more testing to convince themselves that it was correct, and they were just absolutely driving themselves insane on that primary objective. For a physics engine, the primary objective is just a couple lines. It's a couple of loops. It's like 5 lines of code total. And you're just calling your methods, your 3 methods from the objectives. So the primary objective looked fine. They went to office hours and the TA said primary objective looks fine. When my office hours, I looked at primary objectives, say it looks fine, but the problem was actually in one of their other objectives because they didn't do enough testing. They just said, well, Autolab said I'm good, so I must be good. Autolab is not checking for comprehensive testing on your tests. It's just trying to give you a starting point to make sure you don't have any glaring errors, if you don't have any big issues with that. Like the way you set up your test suite, if that's wrong, it's gonna pick out issues like that. So I just wanna make sure that's very, very clear. We'll talk about it throughout the semester because it's one of the common mistakes that I see students up against in really the first 2 years at least of the entire curriculum. Students submit to Autolab. Autolab says I'm good, so I'm good. Well, our testing isn't meant to be comprehensive. So just keep that in mind. Some pitfalls to avoid. All right, with all that said, let's go into the code and solve this lecture question. So first, the lecture question from last Wednesday, the thing that we're testing. Here's my solution for that. This is my solution that I had in Autolab for you to test. If the weight's less than 30, return 5. I could do less than or equal to 30. It had the same effect here. Else 5, that flat rate, plus 25 cents for each pound over 30. I take the weight minus 30, so if I am equal to 30, this is just going to be 0, and I'll get 5 anyway. Weight minus 30, that's my weight over 30, then multiply that by a quarter, charge a quarter for each pound over 30. So I feel like this is correct, but let's do some testing to make sure. So I'm going to go into unit testing, set up the structure of a test suite. The first thing I'm going to say is, oh crap, I got some errors already. I didn't even do anything yet. This is where we have to install Scala test. Scala test does not come with Scala. It's not built into our development kits. It's not. It doesn't come with IntelliJ or anything. It is not installed by default. So we have to get this installed and linked to our project somehow. For that, we're going to use a tool called Maven, and Maven is going to look for a file called pom.xml to figure out how to build and set up our project, and what we'll use it for in this course, what dependencies to install, what libraries to download to be able to run this code. So to do that, we go to the root directory of our project, and we're going to create a file named exactly pom.xml. So I'm going to right-click, new file, pom.xml. If I can type. Life coding is always stressful. I'll make a lot of typos today, I guarantee you. So I have my pom.xml, and I need a file in the right format that Maven is looking for. So for that, for this course, we don't want to get bogged down on the details of Maven. It's a deep topic. Feel free to look through the documentation if you're interested. There's all kinds of things you can do with Maven. For our purposes, I have this example POM file in the course schedule. And I'm just going to cut and paste. If you want to edit this, you want to do more things with Maven, feel free. But for our purposes, if you just want to paste that, we're good. So this is our Maven file, or our POM file for Maven. And it's going to tell Maven, I need this dependency called Scala test. Here's where you can find it. Here's the version I need. And this is where we're going to say each library in Scala has to be compiled for a specific version of Scala. This is where we're downloading the 2.12 versions. I haven't checked recently, so this might have updated, but some of the libraries we use in this course haven't been compiled and released through Maven Central in their 2.13 versions at the time where I was setting everything up. I'll have to check. Someday I'll update everything to 2.13, but as of the mid-semester, last semester, some of the libraries still didn't have their 2.13 versions live yet. So these versions have to match our Scala version, so 2.12 for this course to make sure all our dependencies are going to work. So now that I have my POM, I'm still not good. I still have my errors here. I need to run this file. I need to run Maven on this POM file. And for that, we're going to go to our sidebar, and we're going to look for Maven, click it, and then click that refresh button. And then, oh no, I don't have Maven in the sidebar is one of the big panic moments. This is one of the big questions in office hours on Piazza. Sometimes Maven just doesn't show up. Sometimes IntelliJ, I don't know when it decides this. When I installed IntelliJ, it was just by default in the sidebar. For some of you, it just isn't. I don't know what makes that determination, if it's operating systems or what. But I deleted Maven on here so I can show this off. If Maven doesn't show up, we can click this magnifying glass, search for Maven, and then add Maven projects, select our POM file, and we can start getting that set up. I'm going to do this slightly different. I'm going to go to my POM file, right click, and I kind of have this set up from last time. But there will be, instead of Maven, it'll be add Maven project. Click that, and then it'll get you set up. Here, I already set it up and deleted the file in the previous lecture, so some of that is kind of residually here. I'm going to go to the re-import. That should give me my sidebar, I hope. Maybe I do have to do it like this. All right, I do have to go to the magnifying glass to get it in my sidebar. And then once I hit the refresh button, either here or like I did over here, errors go away. What that did was download Scala Test from the internet, link it to my project, and now have it available anywhere in this project. I can import Scala Test and start using this library. And of course, just because I've been messing with the same repo a lot, I got a few of these here, but some of them won't go away. But anyway, we have that downloaded and installed. Obviously, you're not going to do that and undo it multiple times like I am, so I got some silly stuff going on for this project. All right, so with all that, now we can finally start writing our tests. And I want to write assert, and I want to say assert first object. It imported that for me. Compute shipping cost of, let's say, 10. And if a package weighs 10, that should cost me 10 pounds. That should cost me $5. So, bless you. So I want to set this up, and then I want to run this test suite. So one thing that we don't have here, there's no main method. This is set up as kind of a special thing with this fun suite. So I don't have any buttons in my sidebar here. I can't just run this from the sidebar. This is one case where I do have to right-click the file. I have to go over here, right-click the file, and go to Run, and that'll run this as a unit test, as a testing suite. We run this. I pass my test. I get these green check marks. So I ran this test. That assert was true. So my code's good, and I'm done testing, right? My method's right. No, not at all, of course. So we have this test case, and when I go through this, I'm going to do things that we should not do. I am doing these on purpose, of course. Sometimes it won't be on purpose, but I'll just pretend it is. And in this case, there's something that I did that's very bad that we should never ever do. What did I do here that's quite wrong? Something I shouldn't be doing. Yeah.
You shouldn't be comparing the doubles with the equals.
Exactly. So I should not be comparing doubles with equal here. So now that I ran that quick math, I'm going to change my test case a little bit here. Instead of just 10, I'm going to do some math here. 10.1 times 3. I'm going to expect this to be 5.075. So now I'm setting this up specifically so I know I'm going to have some truncation errors, because I can't represent this 0.1 exactly. And then once I do math on that, I'm going to get all jammed up. I run this, and Scala Test is going to give us some nice feedback. Scala Test does try hard to give us some good feedback here. We were expecting 5.07, but guess what my method returned? This garbage here, 5.07499999999. We have some truncation error. Sometimes you can get away with this, like we did on the first example. You're just using whole numbers, you're usually pretty safe. But you're running a risk if you're using equal. We should never compare doubles like this. We need to do something to get rid of the effects of this truncation. We don't want this hurting our code. We don't want this destroying our tests. So what I'm going to do is write a quick method to be able to compare my doubles in a way that we expect. I want to be able to have some tolerance to this rounding effect, to this truncation. So double B, oh my goodness. Double, I want to return a Boolean true if these are equal enough for my purposes, and false otherwise. Then I want to take the absolute value of the difference, just like we did when we were talking about doubles earlier, and I want to say, is this absolute value less than some small value? If it is, if I'm within a certain range of each other, if these doubles are close enough to each other, I'm going to consider them to be the same. I'm going to say these doubles are the same within some amount of tolerance. And when we have this amount of tolerance like this, we usually, in mathematics and computer science, we'll usually call this variable epsilon. Whenever we have something that should be a very small value, the variable name epsilon, epsilon kind of tells us, it communicates to people reading our stuff that we expect this to be a very small value, some small epsilon. So I'm going to store that in a variable epsilon, and then if I have to make other comparisons, I want to use that variable elsewhere. I'll use it throughout my code. If I ever want to change it, I can just change it once in this constant variable that I'm creating. Now, instead of using this equal equal, I'm going to call my compare doubles, give it these two arguments, run my test again, and now I'm going to be able to compensate for that error, for that truncation, for that rounding error. Now I'm going to pass my tests again, and I'm happy again, because those values were within some small value. This value is large enough to account for the truncation errors, which are going to be very, very small, but this is small enough to not affect the logic of my program. So I don't want this, I wouldn't want this to be 0.1, because now I might have some incorrect code that I'm passing just because my tolerance is way too much. We could even go out pretty far. The truncation errors are out there to quite a few decimal places in most cases. So we can have this be a pretty small number. Now this is good for us. It's going to test our code, but of course we need more test cases. Now we can do this and then manually change our test cases, but I want to show you something that's going to help organize your code, help keep it clean, help keep it readable, instead of having this big block of code. This is fine, it works, but once our testing is a little more complicated, this is going to be a mess. This is going to be a mess of code, it's going to be jumbled stuff. It's just not the cleanest approach. And I saw in office hours yesterday a lot of students using lists for this and trying to store all your test cases in lists, just because that's what I used in Monday's example. I had lists for my test cases, but that doesn't quite get what we want out of this question. Just having one list of inputs, how are we going to map those to outputs? I saw one of you having two lists, one for the inputs, one for the outputs, and then iterating over both of them at the same time, which again works, but it's not the cleanest thing. So I want to show you a way to clean this up, to be able to keep your test cases nice and neat. And for this, we're going to have a good application of a map. I want to have a map that matches my inputs to my outputs, and iterate over them both at the same time to be able to get what I'm getting after. So I want a map of double to double. It's going to equal a map, and now I can have my test cases. 10 should map to 5. Now I'm not going to do my comprehensive testing here. You'll get once we have the structure, you'll get the idea. You just add more and more test cases until it's comprehensive. But I'll add a few. 30.0 should also map to 0.5. 31.0, we want this mapping to 5 1/4. 30.5, we want that mapping to 5, 12 and a half cents. And I'll stop that there. That's enough. Not enough test cases, but enough to prove my point here. And with maps in Scala, you can format these a little different. If you want to have each test case on a separate line, which gets convenient when the test cases get large, this is valid syntax, nice and readable. You know where your test cases are, easy to read, easy to expand. You want another test case, you just add another key value pair there. Maybe I want 0.5 as a test case. It's right there. We have that right there. Now we want to iterate over this map and assert each one of these test cases. We're going to iterate over those keys and values at the same time. So I'm going to iterate over my test cases. And for each test case, I'm going to call my method on the input, on the key, and I'm going to expect that to be the output, this expected output, the value in my map. So I'm going to iterate over all of the key value pairs. The keys are my inputs, and the values are my expected outputs. I'm iterating over the entire map and testing all of those test cases in this loop, and have a nice clean test case. Here are my test cases. Here's where I run each test case. Easy to read. It's not an eyesore. I guess it's a matter of opinion, but I think that looks nice and clean, compact, easy to read, easy for another developer to understand what you're getting after here. Then I pass my test cases. But what happens if I don't? Maybe I have 5.9 here. I have some broken code, or I have one of those incorrect solutions. I want to make sure I fail this first of all, which it certainly will. But when I do fail this, I really don't get any information here. I get the line number that fails. I get, and Scala tests trying to help me out, but it's just saying this line of code was false. Well, I already knew that because it failed the assert. I knew that already, Scala test. So it tries to help, but it didn't really help in this case. This is where we really want the hint text. And you can have the hint text be as descriptive or non-descriptive as you want. You could write, have a string concatenation saying on input this, expected this, actually outputted this. Store the output in a variable and print that out. We can get fancier with this. For now, just for the sake of example, I'm just going to print out the input. Input. I'm just going to print out the input. So I want some hint text, so I actually know what failed. Because just telling me this test failed isn't really helping me much. So now it's going to say, hey, this test failed, and here's what you wanted me to tell you when this assert failed. So now I know that this failed on input 10. So now I can go to my code. Okay, on input 10, what's going on here? On input 10, 10's less than 30. It's returning 5.9. Oh, crap. That's supposed to return 5.0. I can fix my code knowing that test case and walking through my code with that particular input. Now I can run it again, and of course I'll pass. Pass this test case. So to recap, doubles never use equal equal. We always want to compare math.absolute value of the difference. Is that less than some allowed tolerance? If so, those doubles are the same. If not, don't say those doubles are the same. They're outside of that tolerance. Using a map to store test cases keeps our code nice and neat, organized, easy to expand, easy to add more test cases. You just add more key value pairs to that map. No big deal to expand on those test cases, on that testing. And the big question, of course, this will keep coming up, how much testing is enough? Satisfying Autolab is a start. That is not where it should end. The short answer is you should convince yourself. If you are convinced, if you look at your test suite and all the tests that you're throwing at this method, if you are convinced that that if an implementation of that method passes all of your test cases, that it must be correct. There's no other scenario, a crazy scenario that could happen that would be wrong and pass those tests, then that's probably where you should stop. Unless your standards are really low. If your standards are low and you're like, one test case is fine, maybe then you should reassess how much testing you need. But at the very least, convince yourself. Don't just rely on Autolab. Autolab won't be comprehensive. there are incorrect solutions that Autolab will be like, yeah, you did enough testing. So convince yourself. This is one of the big things I want to that will serve you well in the future in 250, 220. If you know how to convince yourself that your code is correct, you're going to be a lot better off in the future and in this course itself. All right, so let's get to our second example. Any questions on that one first? Yeah.
Wait, so what would happen if you ran template one again?
If I ran what?
Like if you tested template one again?
We did run it with the compares double method, and it was able to smooth out that tolerance. So those were close enough, it was within our tolerance, so it did pass the test with that. I can add it back in there, and with calling equals double, we will still pass that test case. So let's get to our second example, and this one's going to be a bit trickier. So let's see what we're doing first. Let's write a method that returns all the anagrams of a string. So given some string, give me all the anagrams. And if two strings, if you take a string and rearrange the letters to come up with another string, those two strings are anagrams of each other. So given a particular string, give me every possible way its letters can be reorganized to form new strings. So this is what we want to do, and of course writing a test suite to test this functionality. And this is where we'll get to a few things that we want to do in the lecture question. It's 3 p.m. So let's write this method. I didn't specify a name for the method. I'm not throwing this in an autograder, so I didn't specify the specifics. So let's name this thing. I'm just going to name it Anagrams. Def Anagrams is going to take in a string and return a list of strings containing all of the anagrams of that string. So this is what I want. And when I start coding this, you'll start to see my kind of style of coding. I don't code in order of the lines of code in a method. I'll jump around a bit because I'll code in order of my thought process. As I think of something I need for this method, I'll code that even if it's out of order of the final code that's going to be written. So when I look at this, the first thing I want, the first thing I know I'm going to do, that I'm going to need, is a list of strings. I have to return a list of strings, so at some point I have to come up with some list of strings. So I'm going to create that new list as my first line, and then the last line of my method is going to be returning that list of strings. So the first and last line of my method, I'm creating some list of strings. I'm going to return that list of strings, so I want to make sure this expression containing this list of strings is the last expression that's evaluated in my method. And then everything in between is, okay, how am I going to get the anagrams in this list? So my approach for this is going to be to iterate over the characters of this string. For each character, I'm going to remove that character from the string, and then I'm going to find all the anagrams of what's left. Whatever's left, I'll find all the anagrams of that, and then once I have all those anagrams, I'm going to take the character that I pulled out and add that to every single anagram that I have from the substring with that character removed. Now if I do that, I should be able to get all these anagrams. So first, let's set up our loop to iterate over the characters of this string. And now I am actually going to want the indices of these characters. And just a reminder, a string is, underneath the hood, an array of characters. And I can't iterate over the indices exactly. I know where I'm going with that. I know where I'm going with that. I don't have a dot indices method in the string. But I need to iterate over the indices because I'm going to want that indice of the string, or of the character that I'm going to pull out. I want to pull these characters out one at a time. So the indice, I want this to be the indice input dot length. So I want to iterate over the indices of the string. In this, I did have a typo in my slides and in my repo. I fixed it by now, but on Monday I had a typo. I wanted to iterate over the indices of an array, and one of my examples was for I in 0, 2 array dot length. That actually wasn't right. 2 does include the endpoint, so I was going 1 out of bounds on that array. I was getting 1 index past the last index in that array. We could do 0 to input.length minus 1, or here I'm using until. Until is going to give me 0 to that endpoint, excluding the endpoint. So this is going to give me the values that I want using until. So I'm iterating over the indices. I want to get that character input dot this char at method. Give me the character at that index, and then I want a new word. I guess new string with that is the original string. Should I have my types in here? I could use the char type here, but I'm going to have it as a string because, never mind. I'm going to use char. I could do .toString. I don't want to get that fancy with it. And I want to construct a new string, which is this original string with that 1 character removed. For that, I'm going to use the substring method. I'm going to take the substring from index 0 to index I. Substring includes the first index, but excludes the second index, excludes the endpoint. Similar to the until method we just used. It's going to exclude the character index I. And I want to concatenate that with the input substring I plus 1. So I want to skip over I and then input last index, get out of there. Length, I had to go to the E. Dot length. So I can get a new string, which is the original string with that character removed. And we see one thing with Scala, I still forgot. I meant to look up the exact rules of when this is allowed or not. But sometimes you can leave off the parentheses. For example, I can delete the parentheses here, and that's perfectly fine, except I deleted the parentheses from my conditional. I can leave off the parentheses of some of these method calls, and Scala will call those methods for us. Just some syntactical difference. You can leave the parens in or out. Either way, in certain cases, Scala is going to be fine with that. All right. So I have the character removed in this new string, and I'll give you a quick warning right now. What I'm about to do, there's no reasonable expectation for you to understand what I'm about to do, which in fact is why we're going to throw unit testing at this. You probably won't be able to follow the code in a little bit, but we're going to use unit testing to be able to test code when we can't eyeball the code and just see that it's correct or not. So if we can't just tell that it's correct, how are we going to be confident that it's correct? That's where our unit testing is going to come in. So I need all of the anagrams of this string. Once I have all of those anagrams, actually let me set this one up. So once I have all of the anagrams of new string, what I want to do is iterate over those anagrams anagram in anagrams and add these to my output. Use a little magic here too. Add these to my output, anagram plus the character I removed. So I have all the anagrams of this word minus that 1 character. If I have all those anagrams, I'm going to append that character to each of those anagrams to get all of the anagrams from the original word. And since I'm doing this for each character in this word, I must get all of the anagrams of the original word. So how do I get the anagrams of this string with that character removed? I haven't really solved anything. I just am faced with the same problem that I'm trying to solve. So, well, why don't I just call this method? I'm using the word anagrams to repeated a variable name. Why don't I just call anagrams? I have a method that gets the anagrams of a given string, and I want the anagrams of a given string. Why don't I just call that method? So this returns the anagrams of the string, and then I'm going to use that to get the anagrams of this string so I can write this method. So I'm writing a method that I didn't finish, and then I'm using that method to finish itself. This is something we call recursion. We'll dive deeper into this later in the semester. But this is something that, just looking at that, you shouldn't take my word that that's going to work. And in fact, I'll give a little spoiler, this one will not work. And that seems like some pretty crazy magic right there. So let's go into the testing. No matter what I say, you shouldn't just say, oh yeah, that's going to work, I believe him, he's the professor. Let's test this. Let's throw some tests at this. And in the interest of time, I'm going to grab my structure from this. 3. Grab all my structure for this. I got to change my types. I'm going from string and to list of string. A, list of A. We don't have to compare doubles anymore. We are in 3 p.m. And come on. 3 p.m. 3 p.m. Don't make me actually do this. It's gonna actually make me type something out. Import code dot 3 p.m. I don't know why autocomplete didn't want to work for me there. Anagrams of input equal expected output. And we get to our first point where we want to compare two lists. And what we're going to do here is use this equal, and we're just going to say, do these two lists equal each other? Scala is actually going to let us do this. This is going to work for us. What Scala will do is check, are these two lists equal size? If they're equal size, it's going to step through each list and each element of each list and call equal on each element. If all the elements are the same and in the same order, this is going to return true for us. So we can use equal here. So let's run this test and see if we can pass, at least on A, just a single character. Are we actually computing the anagrams of A, which is just a symbol? Nope. So I tried to show you some magic. My magic didn't work. Oh, man. So let's go back here and figure out what I did wrong. So here I'm creating a new list, and I'm returning this list. And the only time I'm ever adding something to this list, by the way, this pre-pend shortcut, this is just like using plus equals or minus equals. I can use the pre-pend, that colon equals, same idea as like plus equals. But the only time I'm ever appending or prepending in this case to output is when I'm iterating over something that was returned through anagram. So at some point, something has to add something to this list without depending on something already being added to that list. So here we need what's called the base case of our recursion. Again, a topic for later in the semester. But if the input.length equals 1, I'm going to have the base case be return a list containing just the input, else return whatever we computed. I'm going to run my unit tests with that quick change and pass it. The code works. Of course, we didn't actually use this magic here. We just said, okay, 0 to 1 excluding 1, that's just 0. Char at 0, substring, which is going to be empty string. None of this really ends up doing anything. And we're saying, oh, the length is 1, so just return the input. So we're passing the test, but we certainly don't have enough testing. We should certainly not be convinced that this method is correct after just that input. So we want at least one more input. Does anybody have a 2 or 3 letter word, hopefully appropriate for lecture? Anybody have a word that we want to test the anagrams of? CSE, hey, all right, I like it. So let's try CSE. And this should be, all the anagrams of CSE should be, oh goodness, we'll get there. CSE itself, CES, ECS, ESC, oops, that's not an S, SEC, and SCE. So these are all the anagrams of CSE. If we run this, hopefully that magic work of saying, well, let's use this method to finish this method. And oh crap, my test fails. Something's wrong here. On input CSE, we were expecting this to be the list of outputs, the list of anagrams, but we actually got this list. These lists are not equal. But if we look close enough, we actually have all the right elements. This is actually a valid output. We did compute all of those anagrams of CSE. We did compute the anagrams, so that method did work. Problem is, they're in a different order. When we do equal on a list, the order matters. So we need to do something to take care of this because the order in our problem statement is not defined, which means we have to be able to handle any order. Just like the lecture question today, the order of the prime factorization is not defined, so you have to be able to accept any order. So this is a case where it's our test case itself that's broken. Our testing is broken because we have a correct output that we're saying is bad. The easy fix to this, sort both lists. If they both have all the exact same elements, they're sorted orders. When they're in sorted order, they should be identical lists. So we'll run this, and we should get some green check marks here. Passing the test, we're computing the anagrams. Is this enough testing? I'll say that all the time. I don't have enough time to go in depth because I want to get back to the slides. But at least quickly show you that we are in fact broken. So if I have duplicate letters, so with just those first 2 test cases, you could, with some salesmanship, convince somebody that that's comprehensive testing. I mean, if it gets CSE, like that's a pretty tricky example. Adding more letters doesn't make it much more tricky. So you could convince somebody that this is correct, but actually our method fails on double letters. If we have a duplicate letter, we're actually reporting duplicates in our output. So we can add a line of code, we can add one condition. If this word that we're about to add to the input is already in the input, don't add it, don't add the duplicate. So we can get rid of that. I want to get back to the slides, but that's an example where you could have testing that looks comprehensive. We could add a whole bunch of examples, but if we never add an example with duplicate letters, we actually are going to pass incorrect code. So to recap, lists, you can use equal, order matters. If you don't care about the order, sort both the lists and then say, are they equal to each other? So you can compare those lists. And as we get more complicated questions, prime factorization, you'll write something, it's going to look good to you, you're going to feel good about it, but you're going to be less certain than you were with the compute shipping cost method. Compute shipping costs, there's not a whole lot that can go wrong. Prime factorization, there's quite a bit that can go wrong in the implementations that you come up with. This is where we really want our testing to give us confidence that our methods are correct. So that's when we don't know what's correct, the testing is going to be a lot more helpful. And of course, when is all the testing enough? When you're convinced that it's correct. You need lots of testing. And with that, it gets us back to a lecture question. And I'll see everybody Friday.